My name is Landon Johnson. I'm in Challenge 2016, and this is my video for seminar. I'm in Calc 2000. I did problem number 24 for section 8.8. And the problem is an improper integral problem. And it asks you to find the integral from negative infinity to positive infinity of 2x e to the negative x squared dx. And to solve this problem, what you're going to want to do is split it into two separate integrals to evaluate it over this. So essentially, you can pick a variable to set the midpoint or any real number. To make it easier, we can make it 0. So then you'll have the integral from negative infinity to 0 of 2x e to the negative x squared dx plus the integral from 0 to positive infinity of 2x e to the negative x squared dx. And then, so the proper notation for solving an improper integral is you take a limit. So the limit as b approaches negative infinity, we'll just set b as the infinity is negative infinity and positive infinity because it'll make it easier to look at and it's proper notation. And so you'll have the integral from b to 0 of 2x e to the negative x squared dx. And so what you're going to want to do is do a simple u substitution. We can make u negative x squared, and then du will be negative 2x dx, and then sub it back into the integral. Because you have this extra negative sign out here, you're going to have a negative in front of your integral. And then so you'll have the limit as b approaches negative infinity of negative b to 0 e to the u du, which is negative e to the u. And sub back in, you'll have negative e to the negative x squared. And then evaluate over this interval b to 0. You'll have the limit as b approaches negative infinity of negative e to the 0 plus or minus a negative, which is positive, plus e to the negative b squared. And then you'll take the limit. So everywhere we see a b, we'll sub in a negative infinity. And so the first part is easy. Any number raised to the 0th power is just 1. And then since we have a negative sign out front, it's going to be negative 1. And then for the second part, you'll have negative b squared, and then b is negative infinity. So you'll have negative infinity squared, which will be positive infinity. So then you'll have e to the negative infinity, which is 1 over e to the positive infinity, which equals 0. So then you'll have negative 1 plus 0, which is just negative 1. And then you take all the same steps for the next limit. But this time b is going to go to positive infinity. And so you'll have 0 to b, the integral from 0 to b, of negative 2x e to the negative x squared dx. And then you'll do the same use of substitution, all that. You'll have the same answer. You'll have negative e to the negative x squared over the same integral, the different integral, 0 to b this time. And then you'll have the limit as b approaches positive infinity of negative e to the negative b squared plus e to the 0. And then here it's the same thing, but since b is positive infinity, you can just plug it right in. Negative e to the negative infinity, which will be 0. Any number over infinity is just 0. And then plus e to the 0th power, which is 1. You have 0 plus 1 equals 1. And finally, to solve the whole integral, you'll just add the two split up ones together, which is basically adding the two limits together. So the total integral will be negative 1 plus 1, and it converges to 0.